All right, we're going to look right now at the square root of a function. Now, specifically what we mean here is if we have some kind of a function, f of x, what is the connection with that and the square root of f of x, another function that you create by taking the square root of that. So what happens when you take the square root of a function, if you think about it in everyday language? Now, specifically what we want to do is see how they compare several different ways. We want to compare, first of all, look at the graphs, see how those compare to each other, and then make the connection with how the equations compare to each other. And then along the way as well, look at numbers, look at points, look at tables, and see the connection there. All right, so before we look at any specific examples, we're going to look just in general on some graphs here. All right, so we'll put in a function here, something like, to start with here, y equals x, and we will then do y equals the square root of that, sqrt of x, and zoom in on that important part there where they are intersecting together. Now we want to start to look at what's the connection between these two things. Now the first thing you notice here is they intersect at a couple points, those two. If your original function is x and the new function is square root of x, that point and that point, we can change it around here. Let's turn that one off for a second. Let's make this like 0.5. Let's go 2 minus 0. Too many things there, 0.5x, and then we're going to go square root of 2 minus 0.5x and turn that one back on there and look at what's happening there. Now this one's turned around this way, but it still has those couple intersection points there. And then some other things to notice are the blue graph, the square root function, just stops there. It doesn't continue on. All right, you can put a quadratic up top here. You could say x squared minus 2, and then you could make this square root of x squared minus 2. All right, now you see part of it there, but if we look over here, zoom out a bit, okay, you got the same kind of thing happening there. Now there's 4 intersection points here, and there's a part where that blue graph has disappeared. So what's going on there? How can you tell where these things are going to intersect? How can you tell where the blue graph is going to exist and where it's not going to exist? All right, I could change this around here. Now, instead of having the parabola like this, we could change it around to, let's change it around to 2 minus x squared, and let's make this one the square root of that 2 minus x squared. See what it looks like. Now that looks totally different than we had a second ago just by flipping that parabola over. Now it looks like you have a semicircle there, right? So what's going on? It's still got those intersection points, still got places where the graph doesn't exist. What we're going to do is we're going to look at a specific example here, look at the equation, the graph, and the table of values to see if we can gain some understanding of what's going on here. All right, so we're going to look at these two here. So this function y equals 4 minus x, and compare that to y equals square root of 4 minus x. So table of values here, I'm going to use Excel for this, which I will flip over to here. So we got those two functions up here. We're going to just look at, say, -5, and then for this we're going to say equals that plus 1, so that I don't have to keep entering it. Continue that table down there. Then we're going to look at here, this is going to be obviously equal to 4 minus that value, and then we can continue this down here, and we get those values, right? So that's probably what you'd expect. I mean, just that linear pattern there. We're going to make this equal to the same x values over here, and then this one we're going to make it equal to square root of 4 minus that same x value. All right, and then we're going to continue this down and see what happens here. So we'll go to, say, here. All right, so you have some values. Now they're not all nice whole number values when you're taking that square root. All right, you get a whole number here, up at the top here. Because if you think about that value, -5, square root of 4 minus -5, square root of 4 plus 5, square root of 9, you get the 3. There's another whole number you get down here. because you have square root of 4 minus 0, which is 2. And then you get a couple of other ones here. You get a couple of other whole numbers here. Square root of 3 minus 3, sorry, square root of 4 minus 3 is square root of 1. You get 1, and so on. This one's also a whole number. Now, if you look at what happens to these values from this table to this table, you can make some sense of what's happening here. The only difference between these functions here, between the 4 minus x and square root of 4 minus x, is whatever these values are here, these values are their square roots, right? Negative 5, 9 becomes negative 5, 3. You can think about this like a transformation almost that you're applying to this graph. It's like you're applying a square root transformation where you're taking this value and taking the square root of it. These values are the same. 8, that's going to be the square root of 8. That's going to be the square root of 7. This one here, 4 becomes 2. These all become the square root in here. And then these are two important points here. These points do not change, right? 3, 1 stays at 3, 1. 4, 0 stays at 4, 0. Now, why is that? Well, if you think about it, you're just taking the square roots of these values over here to generate this new table. 1, the square root of 1 is 1. Doesn't change. It's its own square root. And 0 is its own square root as well. Those two don't change because 1 and 0 are their own square roots. Those are going to be the two invariant points in the graph. Now, if I was to continue this pattern on down here, you can think of what's going to happen. You're going to get, our Excel program is telling us that this is saying that it can't calculate this value because it's not a real number, right? That's what Excel returns when it gets an error. Because you got 5 gives you negative 1 in the original function. If we put 5 in here, we have square root of 4 minus 5, square root of negative 1. It's not a real number. From here on, these are not real numbers because these values are not in the domain of this function. The original function, 4 minus x, the domain is all real numbers. You could put anything in that column. Whereas this new function here, that domain, you can only have values that are going to make this expression under the square root sign end up being a number that's 0 or greater. So x has to be less than or equal to 4. So 4 is this where you get 0. Above that, or for smaller values of x, is where you get values that are permitted. And then after that, if you take values that are bigger than 4, you end up where it doesn't give you a real number. All right, so let's flip back over to the graph here, and let's put in our two functions there, y equals 4 minus x, and y equals square root 4 minus x. All right, now if we look at this, we'll zoom out a bit, move this over. The important part of that graph are those first of all, thing you notice are those 2 points that we had there. This point and that point down there. Those are those two invariant points. They are points on the original graph because 3, 1, it works in that original equation, and 4, 0 also satisfies that original equation, but it doesn't change when you take the square root because the expression underneath here is 4 minus x, so if you have 3 or 4, you get 1 or 0, and square root of those don't change. So those are the two invariant points there. The other thing that's important to notice is the connection with the graph for values that are x values bigger than 4. The square root graph doesn't exist. These values are not in the domain of that square root function, right? Because values bigger than 4 for x here mean that this expression is less than 0, and then the square root of that is undefined. So this graph only exists where x is 4 or less. All right? And then beyond that, these are all just the values or the square roots of each of these things, right? You have here 4 was 2 here, right? That point. I can't get quite there. We go. This point here, see if we can get it. There we go. 4 becomes 2, those y values. If I scrolled out enough here, I could find that, say, 9 here. That value that gives 9. negative 5, 9. It's not going to leave the label there. Negative 5, 9 becomes negative 5, 3, just like we had before, values like that. All right? So that's the square root graph. Now I have another table that I'm going to show you here related to this so we can see some other values, because what we want to look at now is what's happening in here. Okay? Between these points. On one side of this value 1, the original graph's bigger than the square root graph. The y values are greater. When the original graph has y values that are bigger than 1, the square root's going to be below it. Because when you have numbers that are bigger than 1, you take their square root, you get a smaller value. But when you have numbers that are smaller than 1, say here, the y value there is, I can maybe stop on there, 0.25. The square root of 0.25 is actually bigger. It's 0.5. All right, go to your calculator if you want and try it. Let's get the calculator here. There we go. If we try numbers that are bigger than 1, obviously, square root of 10, you get a number smaller than the original number. Square root of 789, you get a number smaller than 789. But if you try numbers that are less than 1, bigger than 0, so you try something like square root of 0.4, that gives you a number that's bigger than 0.4. Square root of 0.4 is 0.63 and all the rest of that there. The number is bigger. Therefore, the graph ends up being above the original graph. So you can use these points as kind of to divide up what's going on here. So let's flip over to where I can write on this. And we can bring in a pre-made graph of this. Okay, so there's a table and the graph. Now the x values I used here are a little bit different so we can see what's going on, because I wanted to use some that were in between these values here. So I just went by 0.2 down here for the x values. So we've got these 2 points here. These are the 2 starting points here, important. That one where y is 1, right? So this is 3, 1, like we had. But the important thing is this value is 1, right? The y value. And secondly, then this one down here, it's 4, 0, but the important part there is the fact that the y value is 0. So y being 0 and y being 1, those are both pretty important points. In between there, so that's 2 points here. We've got where y is 0 on the original function and y is 1. Those are key points because they're invariant. When you have then this part where the original y values are bigger than 1, okay, that's up here. When those original y values are bigger than 1, the square root graph's going to be below it, right? So this is below here, below. When you have the original graph's y values less than 1, well, their square roots are going to be bigger than them, right? So that's this section in here where the square root graph's above the original graph, right? So we should write above down there. And then the third spot here is this part where we have these undefined values. Running out of colors here, let's use green. When those original ones are negative, you get this is undefined. Graph doesn't exist, right? Non-existent. How about that? This is when the original function is greater than 1. It ends up being below. When the original function is between 1 and 0, then that square root graph ends up being above. When it's greater than 1, it ends up being below here. And then when f of x is less than 0, then that graph is non-existent there. All right? So let's put this together in a kind of an organized table here, and we'll go left to right here, small to big. So this is where, oops, let's write this as, this is where f of x is 0. This is where f of x is 1. We'll put over here f of x being greater than 1. We'll put down at this end f of x being less than 0. And then in between here we have f of x between those two values. And let's color this table the way we did the one above. There we go. Alright, so let's start with the values that don't change here. So 0, square root of f of x is the same as f of x. So that's one place where they intersect. And the same right here, right? Square root of f of x equals f of x. That's another place where they intersect. Anywhere you have the original function being 0 or 1, the graphs are going to intersect. Those are going to be invariant points. Next, we looked at down here at when the original graph was above, so the function values were greater than 1. That was where square root of f of x was below. So square root of f of x is less than f of x, below the original graph. And in the middle here is where we had square root of f of x being greater than the original function, because it was turned out to be above f of x. And then last part over here was where you had the square root graph was undefined. Square root f of x is undefined. There is no graph there. The values are undefined because you can't have the square root of a negative. Alright, so that's a bit of a summary of where invariant points are, where the square root graph's above, and where the square root graph's below. We should look a little bit more at domain and range, though, and how you can find them and how you can compare them. For our situation here, our two equations, we have y equals 4 minus x, and we have y equals square root of 4 minus x. And we saw how the graphs lined up with each other. Think about the domain and the range just from the equations. The domain and the range of this original function were all real numbers, because it's a linear function that slopes down. It covers all real numbers, both x and y. The square root function, there's only certain values you can put in there for x. If you want to find them without even looking at the graph, you can just look at that part of it and think about it like we did before when we were making those tables of values. You can just write in an inequality here that says, I know that this thing has to be greater than or equal to 0, so you can just write that. 4 minus x has to be greater than or equal to 0. It can't be negative. And then you just solve that to find your domain. I would put that x over there and make it x is less than or equal to 4. Alright, so domain is x less than or equal to 4. So that's obviously different, because that square root function is not going to exist where the original function was less than 0, right? This corresponds to where f of x was greater than or equal to 0. And in the range, if you think about this, well, what you have to have here is that this square root expression is never going to be less than 0. The smallest that square root expression can be is 0. So that means that y, the smallest thing it can be, is 0. So since that thing has to be 0 or greater, y has to be 0 or greater. So we can write that here. Our range is y has to be greater than or equal to 0. And you saw that on the graph, that the square root graph only existed above the x-axis, where the y values were positive or 0. And one last thing we're going to do here is just look at sort of a random graph and try to draw the square root. Alright, so this thing down here in blue is f of x, and we're going to try and draw square root of f of x using some of the principles that we've just looked at here. First thing you should look for is the invariant points at 0 and 1. Alright, we need to look at those things. So I'm going to start from the left here. I'm going to say, here's a point that's 0. Here's a y value of 1. Here's another y value of 1. Here's a y value of 0. And over here there's a couple more. So that's quite a few values that are going to remain unchanged. But the rest of this is going to change. Let's look next at the parts that are above the axis, because the parts below the axis we can just ignore. This part's below the axis, the square root of that's not going to exist there, and likewise over here. But it is going to exist in the other parts here that are above. Let's do some values that we can do easily. This one happens to be 4 here, and I know the square root of 4 is 2. So I'm going to take this point, I'm going to put a point there because it's a 2, and all the way along there, actually right over to here. So you know the thing's going to look like that. And then you could try and put in some other values here if you happen to know any square roots. If you happen to know the square root of 2 is 1.4 or something, you put a dot in there. If you happen to know the square root of 3 is, you know, something or 1.7 something or other, you put it in there. But you're going to know that it's actually going to curve. Even though this is a straight line, the square root is going to become this curve here, so you can more or less just curve it down like that. And if you don't like all those points underneath, you can draw your straight line there, and then it's going to start to curve down here. But what's going to happen here is now this section of this graph is below 1, right? That's 1 there. So this part's going to be actually above it a little bit. If you can draw it like that, that's fine. And it's going to be the same thing on this other side over here. I know that this point's going to be a 2 because it was a 4, but the rest I can just draw in here. It's going to be above, and then it's going to be below like that. Same with the other side here. It's going to be somewhat symmetric, although this is this curve here, so we're going to do our best to try and make this work. We can kind of approximate some of the values in here. It's going to be kind of up like that some way, and then this is going to be above here. It's going to be hard to tell it's above, but that's about the best you can do just for a rough sketch of that square root of that graph. And as we said, it doesn't exist there, doesn't exist here. All right. So that's a look at the square root of a function. If you have some kind of a function, what does its square root graph look like? We have invariant points at 0 and 1, where f of x is 0 or 1. And we have the square root of the graphs below, where the original graphs greater than 1, and we have the square root graphs above f of x where it's between 0 and 1, and then we have it doesn't exist where f of x, the original graph, is less than 1. All right, that's it.